But we are Menai Strait. Welcome back. We are at a location called Church Island, and it sounds exactly as it is. It's a little church on a little island in the Menai Strait, and it looks very peaceful, but this church has borne witness to some of the fastest tidal currents in the whole country as the Menai Strait empties and fills twice a day, every day since the church was built in the 15th century. Now, if you look behind me, the Menai Strait is at its narrowest, one of its narrowest points over here. And when the tide starts to run, it can run up to speeds of 8 knots. Now, just to compare with your typical coastal beach, which normally hits speeds of 2 knots, this will run 4 times faster. And it not only flushes the strait and keeps it clean and free from pollutants, but it also brings valuable nutrients to all the wildlife here. And what's absolutely amazing is that those incredible wildlife, the nutrients travel right across as far as the other side of the Atlantic. So really important ocean currents bringing those nutrients here. Now, the ocean currents, the Earth's circulatory system, if you like, bring these nutrients, but they also help to stabilize our climate. But the question is, what drives these currents, the circulatory system? Well, to show you, we've got a little experiment. I've even got the lab coat because we're going to get ready for some science on the beach. And what we have here is a demonstration, a little experiment, and I have to thank the team at Bangor University at the Ocean Sciences Department for helping us do this, because this tank represents the North Atlantic. Over this side is the North Pole, and on this side is the equator. So let's take a look at what happens at the equator first. Now, the sun is beating down over here, and in order to show you how this affects the water currents, I'm going to put a good amount of red food coloring into that little ladle there. And then to represent the sun warming the surface waters there, I'm going to pour some hot water into that ladle. And what you should start to see is that dye pouring out. We're just going to trickle a little bit more water there. And what you should see is, as it settles, that red dye starts to stream across the surface of the water. That's because the hot water, the warm surface temperatures, rises and stays above the cooler water below. It's less dense. Now, what's interesting is it's starting to be pulled towards the North Pole. Why is that? Well, let's take a look what happens at the North Pole. Now, what we have is a whole bunch of icebergs that we're going to drop on this side, keep them on there, get a few more going, get that nice and cold. And this time, just move that back, I'm going to pour some blue food dye, a good amount of that, and you immediately see that starting to sink. That cold water is more dense and it sinks to the bottom of the surface. So out in the open ocean, this is sinking to depths of over 1,000 meters and heading south across the abyssal plain, amazing environments, over to the equator, and this starts to become like a conveyor belt, a circulatory system, and it's called the Atlantic Meridional Overturning current. Quite a mouthful. But this is what's responsible for what we call the Gulf Stream. Now, the Gulf Stream will start at the equator, and as it leaves the American continental shelf, it becomes the North Atlantic current. And it brings warm water to Ireland, to the British Isles, Western Europe, and keeps our climate a lot warmer than these northern latitudes would suggest. So far, so good. However, a changing climate could change all of this. And what we could start to see, in fact, what we are starting to see, according to the team here, is these warmer surface temperatures, the water reaching way further north than what we've been used to. And it's starting to create something called the Arctic Atlantification. So the Arctic Sea is starting to behave a bit more like the Atlantic Ocean. And in the very long term, this could stall this circulatory system. Now, this is a very long view, possibly in the next century. However, here and now, what we are starting to see with these warmer temperatures moving along are species, exotic tropical visitors, seasonal visitors to our water. So things like this triggerfish here, very much a tropical species. It's now seen almost annually, considered a seasonal visitor, and you can see it there moving through kelp forests. So quite an alien environment for this tropical species. Now, you could say this is quite exciting, getting exotic tropical species on our shores. However, tomorrow what we are going to see is how it's not all rosy for these tropical species when they get marooned here. So that's for now. For now, what we need to do is make sure that we don't get caught out by that tide. And Chris and Michaela, I'm going to let you take it over while we quickly scramble out of here and not get caught out by the incoming tide, which, as we all know, is pretty fierce.